is it's providing evidence not only of accelerated nuclear decay, but also evidence of catastrophic geological processes. Some of the processes that the conventional scientific community say take millions and millions of years to occur, and which are commonly brought up as accusations against believing in a biblical young age for the Earth timescale. So let me explain this fairly simply. You all know what a granite is, I hope. Here's a photograph of a road cut of a granite east of San Diego, not far from the Institute for Creation Research, up along I-8. And in the granite, that's a close-up view, you can see there's light minerals and there's a dark mineral. And the dark mineral is a flaky mineral, a black mineral called, a mica mineral called biotite. Biotite. It's very common in granites, and you see them in granites here in Colorado as well. And in these biotite flakes, embedded in them are tiny zircon crystals. Some of you are familiar with zircon. We mentioned it in the last lecture. It's zirconium silicate. The mineral zirconium silicate called zircon. And the zircon atom is the same size, more or less the same size as the uranium atom. So occasionally a uranium atom substitutes in the zircon lattice, crystal lattice. And so zircon crystals contain radioactive uranium atoms within them. Over time, the nuclei of those uranium atoms become unstable and they decay by alpha decay. And alpha decay is actually the two neutrons and two protons within the nucleus of the uranium atom are ejected together from the nucleus as a particle. And we call that an alpha particle. Two neutrons and two protons. So in other words, the size of the uranium nucleus gets smaller because it was originally 238 particles and ejects 4 of those particles. And we call those 4 an alpha particle. Now, not only does this happen once, where the uranium atom is unstable and it ejects an alpha particle to produce a daughter atom, but it happens more than once. The daughter atom, the first daughter atom, is also unstable, and it ejects another alpha particle and produces another daughter atom. In fact, it happens 8 times before you get down to a stable lead atom. Okay, so when uranium decays to lead, it actually goes through a whole series of these alpha decays, 8 in fact, and a number of beta decays in between. So it goes from uranium-238 down to lead-206. It's actually lost 32 of the original nuclei particles in the nucleus until it becomes stable as lead. So there are a total of 8 decay steps where alpha particles are ejected from a uranium atom before it's transformed into a stable lead atom. Okay, when the zircon crystals are large, say 60 microns, that's 60 millionths of a metre long, that's about the thickness of a hair, the alpha particles, when they're ejected, do not escape from the zircon crystal. Okay? These alpha particles can't escape, but they capture electrons and become helium atoms. And you're all familiar with Russ Humphrey's work on helium within zircons. The helium has actually come from the alpha particles produced by uranium decay. Okay, so alpha particles are actually in the same as the nuclei of helium atoms, without the electrons orbiting them. But when the zircon crystal is much, much smaller, only 1 micron in size, that is, a 50th or a 60th the size of the larger zircon crystals, the alpha particles actually escape. They escape from the zircon crystal into the surrounding biotite crystal. Okay? And so they're like little bullets. If you get a gun and fly it into particle board or what do you call it? Drywall board. We call it gyprock in Australia. But it's the sheets that you put up on the frame and the inside of your house. You leave a hole in it if you fire a bullet through it. Well, imagine what it's doing. These alpha particles are like little bullets that are shooting out from the zircon crystal in the centre there into the surrounding biotite flake. And what happens? You get a discoloration of the crystal structure in the biotite. See that? You can see in the centre there a tiny little zircon crystal, and you can see this halo of damage produced by the radioactive decay. The alpha particles shooting out from the uranium in that zircon crystal. So this discoloured area is called a radioactive halo, which is abbreviated to radiohalo. Now, we see on the screen, this is in 2 dimension, it just looks flat. But remember, the zircon crystal is the alpha particles are shooting out in every direction. It's actually a sphere of discoloration, and we've just sliced through it to look at it under the microscope and take this photograph. Okay, so here's our tiny little zircon crystal. It contains uranium. It's spitting out these alpha particles, but at each of these decay steps, where uranium-238 decays through 8 steps before it gets down to lead-206, each of those alpha particles have different energies at each of those 8 steps. So it's like having a handgun and a shotgun, a high-powered rifle with different, able to shoot the bullets further or not so far according to the energy. And so you can see what happens. Most of the damage to the crystal is done when the bullets stop. So the more powerful the bullets, the further they go,